Welcome back, students. We're doing question 12 of the 2023 paper. We'll read the question carefully. The diagram below shows a curved shape. I agree that it's curved. It's taking these sort of, if you can call them corners, A points on the shape anyway, critical points on the shape from A to B to C. Okay, C is the center of the circular arc from A to B. There's this, oh yeah, so let's see what they mean by that. C is the circular arc from A to B. That's over here, more like. I'll write that again. C is the center, yeah. So we see I'm putting my compass point on C. Now the arc from A to B runs from A, there's A, down to B. Okay, that's the circular arc from A to B. Great. A is the center of the circular arc, so these will be easier and easier as we go. A is the center of a circular arc from B to C, meaning it's part of a circle. And B is the center of a circular arc from C to A. It certainly is. The dotted triangle ABC is an equilateral triangle. Yes, it is. It has side length as marked on my compass. Using only a compass and a straight edge, so we won't be allowed to use the measurements on it, construct one of the axes of symmetry of the curved shape ABC and show all your construction lines. So it has three axes of symmetry. It has one down the middle there, one going up that way, and one going up this way, where the left and the right are equal to each other. Okay, so to construct it, we need to find a midpoint of any one of them. Let's go straight down the page because that's what we would normally do. So we need to find the midpoint of this. Very simple way of doing it. We won't have to change our compass. Is to just finish that arc out down to the bottom. That was arc AB, and we'll finish out. We'll put this here now. Just check that you can see that from the camera position. And we're going to finish this arc downwards here. Okay. It might be at a slight disadvantage because we haven't done all our constructions, or we haven't done any of them maybe yet, but we will be doing them in class, and you'll enjoy it quite a lot. Okay, so now we're having our line of symmetry. Using a straight edge, construct one of the axes of symmetry of the curved shape ABC. Show all your construction lines. So they're all shown. I have to do no more. We're finished on that bit. We'll check the marking scheme in a bit, but let's drive on and try and get the question finished. Write down the size of the angle at C. What they're asking us here is the angle at C. It's no ambiguity. And now they are talking about in the triangle, and that could certainly have caused confusion, but they're talking about this angle. And we know it's an equilateral triangle, that these lengths are equal. And so it's an equiangular triangle, and so this is 60 degrees, because 180 degrees of the triangle divided by 3 equals 60 degrees. So 60 degrees goes here. The length of the straight line segment BC, okay, the straight line here, is 40 centimeters. Now, oh yeah, well that's in it's scaled. Okay, well we'll call that 40 centimeters. Find the length of the circular arc from B to C. Very clever question. Now, our problem solving skills are being called upon. Let's get our hands dirty and let's take, I'll see could I lead you, if you don't know already, I'll see if I could lead you to the answer. So, first of all, an arc, a circular arc, is always part of a greater circle. So, this bit here that we're trying to get the length of is part of this big circle. So we need to know what fraction of this big circle it is. And we know that this angle here is the same as this angle here, it's 60 degrees. So what fraction of the circle is it? It's 60 over 360. Okay. There's a formula for it in our tables. Somewhere in around here. Let's go to page 10, see how we get on. It's the one with the arc. There it is here, actually on page 9. So it's the length of the arc in terms of degrees and in terms of 2 pi r. Remember, all the way around would have been 2 pi r. So we'll just take up the running again here. This is our formula. L equals 2 pi r times what fraction? And the fraction I've already done there is 60 over 360, which reduces to 1/6. So the length we're looking for, or the length of arc BC, equals 2 pi times the radius. Now with this being 40, then the radius is also 40 centimeters. 2 pi r, and then we have over 6, because this is over 6. Okay, now we've 80. We'll put that in the calculator. Did it say anything in terms of pi? You know, it's correct it to 2 decimal places, meaning use pi from your calculator, as they nearly always do nowadays. We used to use approximations, but look, calculators are well and truly with us now, so there's no reason to be using approximations anymore. So 2 pi times 40. I might get in trouble for not having multiplication up in front of the 2, but we'll find out. Shift equals to get a decimal. We're getting equals 41.887. And if there's one kind of message coming across from the style of my video, it is that I'm solving a problem. I haven't done this before, and that's why our problem solving is at the core of everything we do. That's what Project Maths is all about. So don't expect to know it all when you go in. Expect to figure it all out when you're in there. Okay, find the answer in centimeters corrected 2 decimal places. Oops, 2 decimal places. It'll be to here. What am I doing? I'm going up. So 41.89 centimeters. Okay. Let's see how we're doing. So let's grade ourselves. So perpendicular of any one of the sides, construct arcs shown with bisector, continued to the 3rd vertex. Yeah, that's done. Full marks there. Maybe we should have named it axis. Watch the spelling. Axis of symmetry. That's plural, isn't it? I think it's actually, if we're doing one, it's singular. Axis of symmetry. We'll check that afterwards, but I'm pretty sure I'm right there in saying that's singular, whereas they said construct one of the axes, plural. Very nice. Okay, how else did we do? We got our 41.89. We used the formula for the length of an arc. We got our 60 degrees. We're doing great. Is there another bit to this? No, we'll be on to question 13 next. So guys, students, as always, I will see you in the next one.